Good morning, everyone, and thank you for attending today's webinar. So, my name is Max Ramsey, and I help customers of every size, from the smallest startup to the largest enterprise, securely run in AWS. So, part of this discussion today, we are going to cover a variety of topics to help you understand how we think about security and what controls there are and what things you can do to help implement those security controls. One of the most powerful things about the security environment in AWS is that it is flexible enough to meet the needs of a wide variety of customers. Everything from the home user that might be spending a few cents to a couple of dollars a month, all the way up to the largest enterprises and most secure government organizations. And everyone has access to the exact same security controls, reports, and other folks like myself that can talk to them and help them understand how to configure that. So we have everyone from enterprises like Shell, NASDAQ, Netflix, and government agencies like the Department of Treasury and others running on AWS. One of the most interesting things about cloud security is that it changes a few things. Like, for example, we have a conversation with folks that, like our directors of engineering or CIOs, and we often ask them, how do you know what's plugged into your environment in your data centers? And many of them will say things like, well, I know because I did do an annual audit, or I have things that are discovery agents plugged into my network and they update it once a day or things like that. But in our environment, you can actually have a clear...
So apologies, switched out my headphones so you could hear me better. So in our environment, we actually have a very easy way that you can know everything that is in your infrastructure. You can get an authoritative list whenever you want, on demand, every few minutes, even every minute if you want. And that can be done via an API call or via the management console. What gets interesting about that is you can literally sit there and create a script or turn to third-party tools that will capture the exact infrastructure you have running, all the servers, all the databases, all the EMR clusters. And you know exactly what's running, how long they've been running, you know who launched them, and you know exact configurations. So you know the security configurations, what the firewall settings are, and you can actually store those away for future use. Like we have many customers that will actually capture that configuration every 5 or 10 minutes and then store them in S3 for long-term storage, and they do a diff against what was the configuration this time versus what it was supposed to be, so that they can detect when new things are launched and go explore, why was that launched? Oh, that was a known change record within their environment, so that's good. We also believe Auditable Cloud Security is really our way of having a conversation with customers about the art and science of security and how we practice that. But we know that it's not sufficient for us to just say what we do, that you really are looking for independent evidence to say that we're doing what we're supposed to do. So in that means we turn to third-party audits and independent auditors to look to what we're doing, so that we produce the artifacts that they need for their audit reports to hold us against whatever industry or international standard that's necessary, so that they can tell you that we are doing exactly the right thing. We have the plans, policies, procedures in place, and we're creating the artifacts to prove that we're doing the right things. And that is what you can get access to, so that you know that in fact we're doing the right things. Now what's interesting about this is we have an incredible amount of infrastructure that generates logs and move them off into other systems so that we can do our analysis. And what's really good about that is sometimes the log files themselves will show some interesting things, but also the absence of the log file can also show things like misconfigurations. And when you move into AWS, you have access to that same infrastructure so that you can store logs very cheaply and cost effectively, so that you can move them off your servers and move them into that storage infrastructure, be able to do some deep analytics on those, and get that same level of control. You can do that either using traditional tools like syslogs or Windows logging services, or we have many partners in place that can do things like Splunk, Papertrail app, that are built to provide this as a service to you. We also believe that we should be transparent. And so what we do is we work with those auditors I mentioned before so that we can look at these industry standards, and we'll go into these a little deeper, and share those reports with you, generally under NDA. Now, you should take a look at the AWS Compliance Center so that you can find out more about these and how to get them from us. The first one we'll get into is the ISO 27001 certification. This covers the information security management system and how we generally run security within the organization. It follows the ISO 27002 best practice guidelines, and in fact is there so that we can actually make sure that we have all the control sets in place. It covers every data center in every availability zone and all regions. And that's a theme that you're going to see through the rest of our certifications, is that they generally apply worldwide, so that you know that when you go into any region that it has the exact same security controls in place. That way you can really depend on things. The ISO 27001 is a very robust international standard, and you can actually get a copy of what those requirements are, and you'll see that it includes everything from business continuity and disaster recovery through training and a bunch of other controls. The SOC controls are really American-based, but are similar to international standards as well. So the SOC 1 is the core report that we use. We update these approximately every 6 months, so you can get a new one whenever you'd like under NDA. The SOC 2 is a set of controls that focuses on the trust services. So this is the SOC 2 Security. And the SOC 3 is actually publicly available on our website at the Compliance Center. So you can download the SOC 3 to take a look at that, and if you need further information, you could then contact your account manager to get the additional SOC 2, SOC 1, or ISO, or whichever control you need. Now, the SOC 1 itself has a number of control objectives that we'll actually be going into in detail, and we'll save that for a little bit. The SOC 2 itself is the SOC 2 Security, and it actually has things like risk management, the monitoring and control activities, how we do procedures, and how we do communications. Many people are surprised to find out that Amazon Web Services is in fact a PCI DSS Level 1 service provider. And this covers the majority of our core services, so things like EC2, EBS, Virtual Private Cloud, the Elastic Load Balancer, Direct Connect, S3, Glacier, RDS, Dynamo, SimpleDB, Elastic MapReduce, Redshift, CloudHSM, and IAM. So you don't have to do any special configuration. You simply launch the services as you would normally, and you use them. The difference there is we take care of many of the common controls, especially things like the data center physical controls, so that you don't have to worry about those. When you actually request the PCI AOC, you'll get a package that contains the AOC, but also a separate document that really dives into the details a little more deeply to say, well, this is what we do, how we do it, and this is still what you have left to do. So it's very helpful information to make sure that you are starting off on the right foot. Additionally, we have security solution architects that can work with you to help make sure that you fully understand what's left, and you can leverage the work of our QSA so that you, in fact, can really get an easier path to accreditation and run on AWS much simpler. We will work with your QIRA if you do have any issues, and we can support forensic investigations as well. And like all the rest of our reports, we're certified in all the regions. FedRAMP is generally for our federal government, U.S. federal government customers and their contractors. We have achieved our FedRAMP ATO for FISMA moderate systems, so that means that the core government systems that are running on us can generally be ran just fine. This covers all the U.S. regions, so this is not unique to just GovCloud. This is in fact U.S. East, U.S. West 1, U.S. West 2, and GovCloud. GovCloud is interesting in that it actually adds ITAR controls, so that if you have a requirement to meet ITAR or you interact with U.S. federal government agencies, you could choose to enroll into the GovCloud region and work there as well. There's an additional report that we make available because sometimes our customers need more information than just what's in those standards. So we've chosen to go towards the Shared Assessments SIG questionnaire, and this is available under NDA. So it's a very robust report. It has hundreds of questions and the answers to them, and is available under NDA. It's an Excel format, and we update it periodically. But the nice thing about this one is that it generally has the mappings to common things like FFIEC, ISO, COBIT, and PCI, and others already built in. So you can use our base answers and then map those to your own needs. There are a number of additional initiatives for which we participate, but we're unable to actually attain any type of certification as a vendor. So one of the common things here is these will typically cover things like business processes as well as the application space. So we deal with these a little differently. For example, with the U.S. HIPAA, we actually enable covered entities and their business associates to be able to operate, and we will assign the BAAs with them so that they can work in complete compliance with the regulations. Make sure you contact your account manager for that additional information and processes to proceed there. For the Cloud Security Alliance CSA, the CAIQ questionnaire, we make that available in the first appendix of our Risk and Compliance white paper so that you can get the answers. Just download that off the Compliance Center and you can get the answers to that questionnaire. Additionally, if you're doing anything subject to the MPAA, so this is usually best practices for storing, processing, and delivering protected media and content, you will need certain questions to be able to answer it, and we've worked with various companies there to make sure that we've answered those questions in the second appendix of the Risk and Compliance white paper. So let's look at those objectives. So there are 8 overall that we're going to do a little bit of a deeper dive for. The first one is the security organization. So this one describes who the security organization is, who our CISO is, what's their structure, and what's their access within the organization to make sure that they can do the right things, that they have the control and span that they need to in order to make sure that we're running secure and meeting all of our different objectives. The second control objective is really about how we vet our staff. So what are the background checks that we do? And we do background checks based on the level of access that they need. It also covers our notion of minimization of access. So this is least privilege. We start off with this idea that everyone that actually is brought on board has no access to anything. And then based on the role that they have within the organization, they have a needs-based access grant that's tied to our HR system so that as they change roles within the organization, their level of privilege and access actually changes. And they have the right controls to make sure that they're doing their job and no more. With that very rigorous separation of duties, we actually make sure that things like our EC2 administrators have no access into the S3 environment or any other environment. So they only can do what they need to do and no more. And the the system actually makes sure that it gets regularly evaluated and done reevaluated for those sensitive roles. The manager must actually reassert and confirm every 90 days that they are still in that role and still have that need. Another interesting factoid in this one is that we actually don't use the same credentials for managing our environment that our staff uses to log into our general infrastructure, so their work environment, their laptops and such. That separate credential to log into the AWS Management Console is actually done using PKI, so it's not straight up username and password, it's actually public key cryptography. And that's just more trustworthy. So we have the separate credentials so that if there is some type of exploit within our normal laptop environment, our user space, that can't actually propagate into the AWS management plane. Control Objective 4 is secure data handling. So this covers everything but primarily focuses in on how we actually take care of storage media. So we do a degauss, and then we'll actually physically destroy, either using a hydraulic punch or a chipper, every hard drive. So simpler is better in this case, so we don't make any complex rules based on what level of data did that hard drive contain. We simply destroy all hard drives that enter our facilities. For SSD-based hard drives, we actually chip those into smaller bits to make sure that every single chip on that device is destroyed. We also do that to certain types of memory. So there are certain types of RAM that will subject to the same thing to make sure that we've appropriately destroyed everything. Physical security is about how we actually manage our data centers. So you'll see everything here under physical security and environmental safeguards to how we protect them, how we have security guards around the area, how we have the challenge to personnel when they try to enter that environment. So no one has the general access to that environment unless they're supposed to be there. So for example, our CISO likes to tell the story about how he doesn't even have access to the data centers as a regular status. He actually has to open a ticket and get permission before he can go into the data centers. And we use separate badges for our data center access than we do for our normal facilities. So that, again, separate credentials just make it a little more trustworthy. So when he goes in there, the VP responsible has to make sure that that ticket is approved, and then they get access. There's at least 2 challenges before they hit a data center floor. And we have the appropriate guards at all access points and cameras, cooling, the right power, and we're securing those the right way, the right fire suppression. And this also covers how we test that environment and how we make sure that we know that we're not responding to incidents for the first time when they actually happen, but instead we're doing the regular checks that are necessary. For Control Objective 6, change management, one of the things that you'll notice is there's no maintenance windows at AWS. There's no time where we'll put out a notice that says EC2 is going to be out for maintenance from Sunday morning from midnight to 1 a.m. because we actually have to operate on this idea of continuous operation. That way that you, in fact, can manage the infrastructure how you want when you want it. So every change that takes place in our environment is authorized under a very strict change management system. And when we do these deployments, we actually take an approach that's called a one-box deployment. So we'll take that change, roll it into just one box within the infrastructure, make sure it's behaving exactly the way it's supposed to be and the way that we're anticipated it should behave. Once we're satisfied there, we'll roll it to the rest of that one availability zone and then proceed on. And then once we're done with that region, we move on to the next region. So we do that to make sure that we're adhering to our availability standards and that when you've designed systems, you know if something went horribly wrong in that one box or that one availability zone, the rest of the availability zones within the region are still functioning correctly. Control Objective 7 is about data integrity, availability, and redundancy. So these are to make sure that we're doing the right things to make sure that your data is protected and controlled and meeting the standards that we've set for it. one of the best examples of this is with S3, where we have a design that actually meets 11 nines of durability for your objects. So we do all the checks necessary when you upload an object into S3 to make sure that it is exactly bit for bit the right thing that you gave us when you ask for it back. Control Objective 8 is incident handling. So this is to make sure that we have the right processes and procedures in place for mitigating and managing potential issues. This makes sure that our staff are trained on how to deal with these incidents, everything ranging from just regular, normal, day-to-day issues all the way up through security incidents. And one way that we make sure we do that is actually we inject game day scenarios into the environment, so that we might do something like insert an incident so that people know that, hey, there's a massive DDoS attack, and the people responding to it don't know that it's any different from a normal real-life environment. They're proceeding to react and respond exactly as if it were real. So that's how we make sure that when we get in this environment, our staff aren't dealing with these issues for the first time when it really happens. In fact, we're just dealing with them as a regular routine operation. That brings us to shared responsibility. So this is probably one of the single most important concepts that you need to make sure you understand when you operate in AWS. So we are responsible for everything from the hypervisor down through the physical facility. So how we manage our staff, how we manage their rights, how we manage the facilities using all the control objectives that we've been talking about. You are responsible for, in the case of EC2, the OS of your guest machine up through how you've configured the application, how you code it, how you manage your accounts and your users within that, how you configure your security groups, network ACLs, and so forth. So in cases where we actually give you a configuration, like a security group is a good example of this, you determine exactly how you want that configured. For that particular one, security groups start off with no access. So you then open up access into it, and then we are responsible for making sure that that actually works exactly that way and the right rules are enforced. And you'll see that later in the presentation as we get into more of the details of security groups. The real thing here is, because you have the choice of OS, you know how it's configured. You decide if you're going to adhere to a particular secure baseline configuration or if you're going to use one of the various options available in the marketplace made available by partners such as Red Hat or SUSE or Microsoft. You know that AWS is holding a high bar for how we manage security and how we do things. And that gives you the flexibility to actually manage your part of it how you want it done. You know that if you have a particularly regulated application that you're running, that has to have the high bar, but maybe that dev environment doesn't. But it's your choice to control and configure it how you want it. For physical security, we actually have large nondescript facilities. So you'll actually see that we do not have big signs on our data centers that says this is an Amazon Web Services data center. Instead, we have the robust perimeter controls that you'd expect. We have the fences, the berms, all those things. And I mentioned earlier that there's at least 2 factors needed for authentication to those data centers, and that it is all need access based. And we actually look at those. We see who's gone through, we verify it, and our auditors actually do their work to make sure that we've done our checks and that all those things are in fact done based on the correct records and authorizations. That brings us to this idea of regions and availability zones. So we use the region as the boundary for isolation so that we will not initiate the movement of data outside of a region. So once you put data, a server, or upload something into S3 into a particular region, it stays there. we have many services that will actually replicate that data between availability zones within that region. But you're never going to put data into US East and then suddenly find it in Dublin, right? Because you actually have that power, and that's your choice for how it goes there and when it moves out of it. And that's really one of the key pieces that's there for being able to achieve compliance with a variety of regulations. It's also your technique for being able to move compute power closer to your regions. So we have quite a large number of customers that deal with a global customer base. And they'll use the region concept to be able to move compute and data for those regions, for those customers, into the region that's closest to them for the best performance. So as we move into network security, one of the things that you'll find is we actually take care of a lot of things. So we mitigate hundreds of DDoS attacks, and customers never even notice them. You get many controls to actually defend against DDoS yourself, in the sense that you have the ability to draw on things like CloudFront, which has many interesting controls in there. And you have elastic load balancers, and you have auto-scaling groups so that you can actually grow. And one of the more interesting things there is if you do get attacked by DDoS, most of the very simple ones you'll never see. So instead, what you'll really see are those that are indistinguishable from normal user traffic. And we don't auto-mitigate those ones because we have many customers that will depend on that exact scenario. Things like Super Bowl ads, where they'll go from no traffic to a tremendous amount of traffic all at once. So in those scenarios, we actually look for you to notify us that you are in fact having a DDoS, not normal user traffic. And then we can help you defend against that. Man-in-the-middle attacks are best mitigated by using SSL endpoints. So you still have to sign all the API calls, but by hitting our SSL endpoints, you actually get additional layer of security there. In EC2, you'll find that things like IP spoofing are prohibited, port scanning is prohibited, packet sniffing is prevented. You can, in fact, put a NIC in promiscuous mode, but what you'll only ever see is the traffic that's actually destined to go to that particular server. And that's all part of the security controls that we'll talk about shortly. So using Amazon EC2 to really describe controls of the rest of our environment, we have this idea of the host operating system. So this is the physical machine and the hypervisor level. So this is what we control. And we do the bastion host approach. So an AWS admin must go to a bastion host where they authenticate using multi-factor authentication. And from there, they are then able to access and manage the control plane. And everything they do is logged and audited, reviewed internally, and verified by our third-party auditors. So we have very tight controls over what they can get access to and how they do it. There's not a persistent connection from an admin's desktop straight into the management environment. That just doesn't happen. And that actually mitigates a large number of attack vectors right there. The guest operating system is what you control. So the OS is yours. You own root or local admin. An AWS administrator cannot actually log into that box. And that actually leads to some awkward situations in like support circumstances. So if a customer calls us saying, hey, they need help to actually unlock their server, we actually can't help them do that. So once that initial login for, say, a Windows server is downloaded and decrypted, we don't hold on to it. And many customers are able to actually change the way their users are authenticated against the OS. So they might use an Active Directory authentication or a PAM module to authenticate against the LDAP or things like that. And we actually have no visibility into that at all. The stateful firewall here we're talking about is really a mandatory, inbound, default deny, stateful firewall. And that's the security group. When you move into VPC, that actually becomes bidirectional, inbound and outbound. And then we add in a couple other controls, such as the network ACLs. And then, of course, we have the signed API calls. So you must sign those calls using your AWS key to make sure that these are authenticated calls on your behalf. So taking a little deeper look at the way we implement that host-based firewall, what you'll see is that it actually lays between the physical server resources and the hypervisor itself. So we actually create these virtual interfaces and present them to the hypervisor, which then presents them to the instances running. That actually forces any communication between servers, even if they're on the same physical host, to run through our environment, so that if you have, in this case, two instances on the same host that need to communicate with each other, that traffic must come through those security groups, and that gives you essentially a private firewall sitting right in front of the NIC of every server that you cannot bypass in any way. One way you can use that is to actually create a web tier, an app tier, and a database tier, and maybe you yourself will take the bastion server approach. And in this situation, you would open up your web tier to web traffic from the world, and then maybe over HTTP and HTTPS, and then you would actually enable the app tier and web tier communication. But what you're going to do is actually enable it so that the app tier is able to listen to servers from the web tier, and you're going to refer to it by the security group name. The nice thing about that is that the participation in that security group is controlled by us, since we know every single virtual machine and what security group it's supposed to be a part of. There's no way to spoof that because it's not based on just IP address. We assert that that server is part of that security group, and when the web tier is trying to talk to the app tier security group has allowed that traffic and only traffic from that web tier security group to come into it. You do a similar thing for the bastion host, where the bastion host you would open only to perhaps your corporate data center or some known trusted address, like such as maybe the specific address you're coming in from at that moment in time. And you'd only allow SSH or RDP into the other tiers from that bastion host itself. Now, using this approach, you can actually effectively recreate the multi-tiered DMZ, because you would explicitly only allow those. So on the right, what it effectively becomes is things can only come in the front door to your web tier, only go down from the web tier to the app tier, and from the app tier to the database tier, or maybe you're using RDS, so you'd use the database security group to enact that final one. And then, of course, you have the bastion tier able to talk to all three. That actually gives you a tremendous amount of control and recreates familiar environments that you might already be used to. For those that actually want more control over their network, we have the virtual private cloud. The virtual private cloud is nice because it actually gives you a large number of controls for you to create your own subnets, to define the complete IP range of that virtual private cloud. And you can even get down to the detail of specifying exact IP addresses that servers will have. Now, you can use a wizard to actually define this through the management console, or do it through the APIs, or a CloudFormation script, so that you can recreate these virtual private clouds on demand. Connectivity to those can be through a variety of ways. You can decide if you want to enable the internet gateway to take advantage of our internet pipes, or you could decide that you're only going to allow traffic in via the IPsec tunnels and essentially do site-to-site VPNs so that only your sites or sites that you've actually connected into it are allowed to move traffic in or out. Or you could take advantage of Direct Connect. Direct Connect would actually let you sit there and create a private connection between your data centers into the VPC backbone. Whichever mechanism you choose, you're fully in control of that. So looking a little deeper at that, the virtual private cloud is logically isolated environment. You specify the IP range. You get the stateful inbound and outbound controls via the security groups, and the stateless inbound and outbound controls via network ACLs. You can attach elastic IP addresses to any instance you want so that you can have that access get to become addressable via public, or you could bridge it. Many customers will actually do a combination so that they can have a web tier that's accessible via an elastic load balancer, and then we'll deploy an internal load balancer, elastic load balancer in internal mode, so that the web tier can talk to the app tier, and then so on. But the choice is yours. And they may even still have the VPN or the direct connect so that they can actually address the VPC as just another data center. So taking a little deeper look at those network security controls in a VPC, you'll see that instances, when they communicate, have to go through the security group layer. And then when they attempt to communicate outside their subnet that they're in, then they go through the network ACLs. And this is true regardless of where the instance physically resides. If they're even on the same physical host, if they're crossing a subnet boundary, they'll have both the security groups and the network ACLs for inbound and outbound to be able to pass to make sure that's authenticated and authorized traffic. One more option that you get with a virtual private cloud is to be able to decide that you want to only use dedicated instances. This is an option to make sure that essentially what you're doing is turning our multi-tenant cloud into single tenant, and that's per account. For basically a $2 fee per region if you're running one or more dedicated instances in there, and a small hourly charge addition to the normal instance price. You have the flexibility of saying you only want specific instances to run dedicated, or you can configure an entire VPC to say that every server that runs in this will run dedicated. And this may help achieve some regulatory concerns. So you have a variety of different options here. In the commercial cloud, you can take advantage of the various things here, where you can actually decide how you're going to control it, how you're going to protect it, what the security groups are. In the virtual private cloud, you add in the logical isolation and the optional physical isolation. And then if you choose to run in GovCloud, you add in the U.S. persons only operations from our part and the ITAR compliance. All those are choices within your account, and you can choose the one that best suits your needs. So let's talk a little bit about access control. This is usually one of the top considerations when you decide to move into any cloud provider. The questions that they usually ask is, why do they want to control something? How do they get to control it? And many people will come in with this idea that very traditionally, I want to have users that I control in groups with different levels of access to the environment. And that actually is the core of the AWS Identity and Access Management. You have the ability within an account to create users and groups. Each user can have their own access key, their own optional management logon for the management console. You can enforce password complexity rules of your choice on there, and even decide that each user must have an MFA device in order to log on. So the policies actually control access to every AWS API, and you can add things on there like must be using the SSL endpoint or must have authenticated via MFA within a certain amount of time, like say 5 minutes. And certain services, such as EC2 and S3 and many others actually, have a deeper level integration where you can control the resources within that service. So for example, with S3, you can get down to a level where you can say, this user has access to this particular folder within this bucket, or even has access to this object, and no other user has access to that. In EC2, you can use tags to control access so that you can say, this set of servers are actually for application A production, and this other set is application A dev or test. And I'm going to have a subset of administrators that have the ability to terminate or take snapshots or do things with those production servers, but more of my admins can actually do things on the dev and test servers. The important thing to understand is that this is about how you authenticate to manage AWS resources. This is not for operating system authentication or applications. For things like that, you should actually consider using LDAP or Active Directory, traditional approaches to authenticate against that. There are actually a number of tools that make that fairly easy. So you can find various Puppet or Chef recipes that will allow you to integrate into your on-premise Active Directory or LDAP. And we have partners like Okta and Ping Identity and others available in the marketplace that can actually help you as well. So taking a little deeper look. So if you look at the command line interface, you're going to use your access and secret keys to make those REST calls, or the default using the SSH keys for access to the EC2 instances. Now, I do have a number of customers who will actually use things like a Chef recipe to integrate that particular server into an Active Directory, even their Linux servers, so that they can then use their normal Active Directory credential to authenticate against that. For the API access, it's going to be signing those calls using the access and secret keys. And optionally, you can add in the multi-factor authentication requirement. And then the web UI is the username and password that you created, and optionally the multi-factor authentication. Many people assume that just because you create a user that they automatically have access to the management console, but that's not true. That's actually a choice. You could create users that only have API access or users that only have the management console access. Additionally, other portions of the website, such as where billing is, are controlled separately, so you can make sure that you have the exact access that your users need to do their jobs. For the multi-factor authentication devices, what's nice about this is it works with the root account or IAM users, and there's no additional cost. The only cost that would be involved is if you choose to use the hardware MFA, and last time I checked, that's offered by Gemalto at about $12.99. The virtual MFA is actually completely free, so you can use the Amazon AWS Authenticator, available for Android devices, or others like the Google Authenticator that's available for iOS and Android. And then we also make available the CloudHSM. This is available for customers that have a regulatory requirement or other need that drives them to wanting to actually have a physical device. So this is a standard SafeNet Luna SA that is tamper resistant, and we have the processes in place so that when you provision one, you actually completely own that appliance. And that brings it in compliance with the common criteria and the NIST FIPS 140-2. So you go through a process that will actually remove our access to it completely so that you are in full control of it. That will help meet some very strict contractual and regulatory compliances and will give you a reliable key store in the region so that you don't have to leave the region to gain access to an HSM. So it makes it very simple because we actually map it into your virtual private cloud so that you're the only one that can gain access to it, and use standard SafeNet clients to be able to actually access the keys or manipulate it. Additionally, they make additional features available, so like you can actually pair up multiple HSMs or get a backup HSM from SafeNet so that you could replicate your keys and back them up to a different location if you choose to. I want to spend a little bit of time talking about Trusted Advisor, part of our premium support package. It does a wide number of things, but one of the more important things from a security and compliance perspective is it actually does a lot of automated security checks so that you can actually see things like whether or not you're following best practices for what ports you've opened up in your security groups. You can see whether or not you're using IAM and whether you have MFA invoked. You can take a look at your S3 policies and see if they're overly permissive, like if you have buckets that are actually read or writable from the general internet instead of just a secured subset of the users. And it does things like to make sure that you are taking advantage of fault tolerance so that you have snapshots and backups of your servers and your EBS volumes. If you're doing multi-AZ deployments or you're taking advantage of the redundant VPN tunnels for your VPC instead of just the single static ones. And that's actually something that's really valuable because it can proactively reach out and check these things for you. While we're at it, you should make sure that you've enabled the MFA for your root account. So if you know that you're not using that multi-factor authentication when you log into the management console, or you don't see that little green check mark on Trusted Advisor, that's one of the things that you should do right now. And we are including a link to this blog so that you can see how to do that for your root account and your more trusted users so that you can make sure that you've locked down your account appropriately. And finally, I'm going to leave you with some links to various security and compliance and architecture resources. So the first one on the top left is the Security Center, where you'll find the security white paper. You'll find a bunch of security best practices, and you'll also find the security bulletins, which we make available as an RSS feed. One of the things that people don't actually realize is that you can, in fact, do security testing of your EC2 instances. And there's a very simple process that you'll find on this site for you to follow to be able to register your security tests so that we disable the various alarms on our side to make sure that you have a successful test. On the bottom left you'll find the Compliance Center, and here you'll find the Risk and Compliance white paper and more information about all the certification and accreditations that we've talked about so far. On the top right is the Architecture Center, and this is a good resource to have for finding reference architectures to very common patterns that our customers have, a ton of white papers and webinars that can help walk you through a variety of things. And then finally on the bottom right is our security blog. So this is where we'll release smaller articles that are usually more technical or focused to find out what's going on in latest security, stay up to date on compliance, or how to do something. Occasionally we'll focus on a partner, or we'll do things like the MFA tutorial I mentioned earlier. So we're always looking for feedback, whether it's on our security or our compliance or reports. If you have a particular compliance regime that you care deeply about and we haven't discussed it, please mention it to us so that we can take a look at that and see if it's something that would be generally applicable to our customer base or if there's something that we can do to help you achieve that. So thank you for your time, and at this point we'll take any questions. Okay, so the first question is clarify the difference between the web GUI and the API calls into infrastructure in terms of control. So really what we're talking about is the API itself. That's the core. And that's the one where we actually go in and control the access. You can use IAM policies to make sure that only the right people have that authenticated access. The web GUI is the management console. So if you go to aws.amazon.com and go to log in, that's your management console and the web GUI. It actually uses the same APIs on the back end. So if you've locked something down to say can only come in from a certain IP address, when you go to make that call, that same check will be enforced. So that's not a separate set of security controls in that sense. It's the same controls enforced no matter which way you come in. The main difference there is you can control whether or not you let people actually log in to the web GUI or not. All right. So I hope that answers that question. So the next one is the AWS VPC seems to lack the depth of logging that I need access to. VPC logging available directly from AWS, or is AWS expecting that the logging VPC will be the client responsibility? I recently had problems with VPC flapping. Was not AWS but. Okay, so I believe that this question is really going into the level of logs that you have about the IPsec tunnels into a VPC. So if you look at the VPN gateway, it gives you the status of the health of those connections so that you can see whether or not it's actually just the one or if it's both tunnels up if you're using the redundant IPsec tunnel, and you can get information there. If you need more access to that information, then you can open up a support ticket and work with our engineers to make sure that we're seeing the same thing that you're looking for. For that level, you ideally would be under developer support, or the bronze support at least, which is a flat $49 a month, I believe. And that gives you the ability to open up the tickets and gain access to our 24-hour support environment. And of course, we have higher levels of support that goes up to our enterprise support, where you actually get a specific technical account manager that actually will work with you with 15-minute SLAs. But I hope that answers that question. Okay. The next one is, please suggest how AWS deals with internal security threats, any tools which you use. Actually, we deal with this a lot, and that's actually a very detailed discussion. And the first one I would offer is take a look at the security white paper and the risk and compliance white paper, because when you look at all the controls in there and our use of bashing hosts and a lot of the common questions that auditors will ask, those questions are in the risk and compliance white paper. Our use of bashing hosts and the technical enforcement of those controls are really in the security white paper. But start there. Those are, let's see, the security white paper is about 60 pages long, and the risk and compliance white paper is significantly longer because we have those two appendices in there. But that should give you a tremendous amount of insight into how we deal with internal security threats, and also focus in on the way that we manage access and the separation of duties, and that we do the checks and balances to make sure that people are in the right role with the right access. Additionally, we do a tremendous amount of logging internally and monitoring internally to make sure that only known things are happening in the environment. So if you have further questions after you take a look at those things, I would encourage you to reach out to your account manager, and we can have a more detailed discussion about that. Okay. Next one, is there any white paper talking about the forensics investigation supported by AWS? There's not a white paper about that, but we can in fact have that conversation if you'd like. Either reach out to your account manager, or you could just send me an email. My email address is on the slide right there, and we can arrange for that conversation. Typically, that is one that happens under NDA, but we'd be glad to have that. Looks like some of the links are not clickable. So are we going to make all the links available? Okay, so in the follow-up email, we'll make sure all the links are there that I've referenced in the document, so that should take care of that. Okay, and then appears that there are a bunch of statements about the volume that I think we took care of. Okay, so I believe that's all the questions at this time. Please feel free, if you have any more questions, to send them via email, and we'll be glad to respond. All right, thank you. Have a great day.